Same concept. We're asked to solve a system of equations. This time, the equations are both quadratic. So let's first take an estimate of what could the solutions look like. These are the possibilities we have. We could have a parabola that opens up, for instance, and one that opens down, and this would be a case where they never touch, which we'd say there's no solution. Or maybe one opens up, and one opens down, and they just barely touch, and it's at only one point. So there's one point where there's a solution. Remember, the solution is the location where they cross, or they intersect. And that solution has an x and a y value. We also may have something similar like this. One's up and one's down, but this time, how many times do they intersect? Twice. An x and a y value for this point, this location, an x and a y value for this location. Does anybody know the last possibility? The last possibility is they could overlap. There's one equation, and here's the second equation, directly over the top. So they have every single point in common, which means they're continuously intersecting, and we'd say there's infinitely many solutions. So how do we do this problem? Well, we start by setting them equal because we already have y equals. So let's set these two equal. The next thing we have to do is we can't do anything before we FOIL here. So FOIL stands for front, outside, inside, last. Front, outside, inside, and last. Okay, and here we go. I'm going to combine like terms. And now I need to combine the left and the right-hand side. So left and the right-hand side. There's no wrong answer, but there's definitely going to be an easier answer. So do you think it's easier to move the left to the right for this particular problem, or the right to the left-hand side? Just think about it yourself. No wrong answers, but an easier one. I'm going to choose to move these over to the right-hand side because I want to have a positive x squared value. So when this moves over, it becomes positive x squared. When this moves over, it becomes positive x. And when this moves over, it becomes negative 12. There's nothing left over here. We've moved everything over to the right. Now I'm going to combine like terms. 2x squared plus 8x, and there's nothing left on the constants. Louise, tough question. What can I take out of both of these terms? I can take out an x. There's something else I can take out. A 2. And what would I be left with? 2x times what is 2x squared? X. And 2x times 4 is 8x. So just like the previous problem, either this first part equals 0 or the second part equals 0. Zero divided by any number is 0. So we have two intersection points. I can see the x values of those locations. I need to know the y values. How do I find the y values? Go back to the original equation. Do you think the top or bottom looks easier to work with? There's no wrong answer. Okay, I'll write down the bottom. So I'm going to start with the 0. 0 plus 3 is 3. 0 plus 4 is 4. 3 times 4 is 12. Now I'm going to do a negative 4. Negative 4 plus 3 is negative 1. Negative 4 plus 4 is 0. 0 times negative 1 is 0.